Good afternoon, everyone. How you all doing? I'm Jerry, and I'm going to be giving you the facts today about our technology. And I'm going to have two aspects to this. First, I'm going to talk about expert integrated systems, and I'm going to give you the facts on that. I'm also going to talk to you a bit about our software stack as well and give you the facts on that. So you ready? Good. All right. First, expert integrated systems are in our DNA. Now, the black and white picture up there resembles pictures that my dad would show me back in the day. My dad spent 35 years at IBM and would show me and tell me stories about hardware and software engineers working together to produce a single integrated outcome, engineered. And today, there's a picture there of two of our engineers working on Pure system. That has not changed. That is very much in our DNA. And this is not, as Steve said, about bundles. This is about a computer scientist and electrical engineer sitting down and sharing their skills, as I said, for a common outcome. Now, a little bit of proof behind that, some facts behind that. When you look at our Pure system, we've been boasting, and it's true, about our 4-hour startup time. And that is when you cable the system in, you boot it, it takes 4 hours until you can submit your first and run your first application. That's pretty amazing. All right? Our competition claims 24 hours. Now, I'm going to show you a short video of that onboarding. But before I show you the video, let me just tell you about some of the work that has gone on behind the scenes to make that 4 hours possible. Again, and this is the epitome of the DNA that we carry around within us. Again, software and hardware engineers working together. We cable the boxes back home, all right? And we have an architecture and design and patents that we filed about how to cable the boxes such that you do it once. In our competition, when they upgrade, you have to re-plug in wires. With us, we've designed it in such a way, because we've talked together, how we can do it just once, and if you upgrade, you don't change anything. The same is true for how we manage software upgrades. Everything from microcode, device drivers, operating system, and middleware. We've not only designed it so that it can be installed. That's a one-shot deal most of the time. But we've designed and patented life cycles into this. So we're ready for the upgrade. And a lot of this is just formatting the storage arrays take over 2 days. And that's value we provide so that you don't have to do it. So a lot of work goes into the following video. And we sped it up because we don't have 4 hours here to go through. So just a little bit about what's happening behind the scenes. We initialize the system after it's powered on. Part of the initialization process is to describe your enterprise. Tell us about the LAN setup. Tell us about some of your external systems. Perhaps you have core services like directory systems, security systems. We want to be able to integrate with those. And again, in 4 hours, we have all that booted up, and you're running your first application. And as I said, that's not the case with our competition. So expert integrated systems is something we've been doing for years. My dad was doing it back in the day, and I'm a second-generation IBMer working on expert integrated systems. We have 3 tenets: built-in expertise, simplified experience, and integrated by design. And I want to give you the facts on those. In fact, I'm going to be sharing with you 5 design principles or design points that back some and demystify some of the things that we've done as we engineered this system. Before I do that, I want to give you the motivation as we were doing this work. What is the motivation, and how did we get here? Well, from an industry perspective, over the last 20+ years, wonderful things have been happening around open systems. You all have freedom of choice from network, storage, server, VMs, app, and database. And free economics have been part of that, where vendor A competes with vendor B, drives down the price, drives up the quality in most cases. Steve mentioned some cases where that's not true. And this is wonderful, except for one thing. You all have to deal with this stack, right? And there's probably tens or hundreds of thousands of points of variability across that stack that you all become experts in. And it's daunting. In fact, in a Douglas Adams-like, probability engine, one might come up with the thesis that systems should never work. It's just too many possible things to go wrong, but they do work. And they work at the expense of all of the expertise we've gathered up during the year. So that really brings into our first design point. Balancing open and expert. Balancing standards while providing a prescription. Right? This is as our team went along and designed this. Supporting application compatibility. Right? 100% Java and JEE capability in Pure Application System, WebSphere is inside. But as Steve mentioned, we have some wonderful tools that help you onboard third-party Java and JEE applications, including WebLogic. Steve also mentioned the 98% Oracle SQL compatibility. And again, we have DB2 inside. And with their database compatibility mode, it's very impressive how we can onboard existing applications. Another key point is the very same tools that we use, and I'll show you an example of those in a second, on how we capture our expertise and build patterns. We give you those tools. And they're built around open standards, OVA, OVF, open virtual format. These are standards that we're working in. I challenge you to challenge your vendors to stay true, because over the last many years, we worked hard as an industry to level the playing field with respect to openness. Java, SQL, these are all standards that are the foundation. We don't want to undo that. So ask your vendors about the tools that they're using and the standard formats. OpenStack, right? We're integrating with OpenStack, and we're part of that community. All right, so again, this balance is key. So let's go one at a time, and I'll talk about some of the design points. I already showed you the up and running in hours. And again, back to my dad, he was a chemist physicist, so I have to think in terms sometimes of that to make analogies. But the 20 to 30x speed up in deployment, this is not marketing. There are facts behind this. And the reason is, for the chemists out there, maybe you can bear with me a little bit. But most of the world thinks of their system as a set of atoms, single individual pieces. You all know that your enterprise applications are not that simple. It's not about one piece. It's about a collection of capability coming together to power some workload. I think about that as a molecule. So we support molecular virtualization. We allow you to virtualize a collection. And the interesting things about molecules are their chemical bonds, right? The things that connect them together. And in this analogy, that represents the configuration information that you all have to read red books, white papers, attend seminars to understand how to put these things together. Right? So when I talk about 20 to 30x, we're not dealing with individual pieces. We've innovated a set of techniques around molecular virtualizing systems, and dispensing those systems, and that's where the gains come from. But it's not just the pieces, it's the behavior. How do you capture the behavior? Built-in workload management, systems monitoring, maintenance, upgrade. This is another piece. I get on a lot of planes for people who are upgrading their systems, their applications. A lot of labor goes into that. In fact, one of the early Pure Application Systems customers looked at this, and as they started onboarding, they realized that we had built-in monitoring, and it was just part of our patterns. And they said, geez, we have a lot of CA licenses for doing monitoring. If I take that out of the equation, this alone pays for the Pure Application System box that we bought. Right? So a lot of value built in. Not just the componentry, but the behavior, and that's really where the savings. So design point number 2 and design point number 3. Application-like, pre-installed, pre-integrated, not just delivering the molecules, but delivering the behavior around management, upgrade, et cetera. And I'll go into more detail on that. Single pane of glass, another engineering feat. melding hardware and software perspectives. You're going to see that in a demo. One console, bringing both together. So now our competition. 24+ hours setup time, and you get an OS prompt. Now, you don't have a running application. Software then must be installed, configured, management software required, and every piece of the user interface is different. Again, it's more like a bundle, and when I say we have an engineered system. In fact, if you go to YouTube and you see there's a video on a gentleman who, one of their lead architects, is installing a system, and he makes a short comment at the beginning. He said, I read the documentation, and now I'm about to venture into this 24-hour setup. Andrew, can you bring me the documentation just to show me what he read before his 24-hour? So this is real stuff, folks. This is their documentation. So you must be the expert. You have to read this and understand how to configure networks and format storage before you can actually get going. So when we talk about simplified experience, it's building this sort of knowledge into the system, automating it, virtualizing it so you don't have to. Thanks, Andrew. All right, that's point number one. Point number two, building on that previous one, is built-in expertise. Patterns is the innovation here. Being able to create those molecules for you. Web app and database are foundational, and so they come in the box. And of course, they're powered by all the things you know and love. And I'll reiterate, it's not just database and app, but it's, again, the life cycle around that, being able to do upgrades of those components. Right? When you buy the web app pattern 1.0 and you do an upgrade of that, you upgrade to 1.1 or 1.5, we don't send you all of the upgrade and maintenance for DB2 and WebSphere. Right? You upgrade it almost like you would do, and we actually call it a firmware upgrade. So we're upgrading, again, appliance-like. We have an edict that Robert and the senior management team is saying, this is the way we're building software around workloads. So BPM workloads, SOA workloads. And as I said, the same tools that we use to compose, we have a tool that internally we call Icon. It's an image construction set. We share that with our ISVs. We have 80+ ISVs in our catalog, so they're using the same technique. So we're open. We're publishing how we do it. Built for cloud, this is best shown. So I'm going to show you some of the work around how we do the virtualization and pattern-based provisioning. So design point number 4, I think I've explained many of the points there. Capturing code. We have a couple of patents that we filed around virtual systems. Again, this molecular thought, capturing all of the pieces needed to power a particular workload, and virtual applications, where middleware virtually kind of hides, and now you're just dealing with application components, and I'm going to show you that in our example. Capturing behavior. Now, I've never worked on Z, but I thank God that I know a lot of people who have in my career, and I've learned a great deal from them about behavior and qualities, and what does it mean. 2 examples, intelligent workload management. All work in these IBM systems is not created equal. If you're a commerce company, buys are something you care about. You care about browses, too, when people are browsing your site, but when a buy comes through, it should cut to the head of the queue. Right, so that's intelligent workload management, understanding the business importance of workloads. We're baking that in. First, failure data capture. Again, a feature that we've had around Z forever. We've brought that in through our platform here. The idea is simple. If a customer application goes down, the last thing they want to hear from us is go recreate that problem, and then we'll help you. Right, so first, failure data capture, a system is coming down. We're actually capturing last will and testaments of all the components, and that gets sent to us so we understand the nature of the behavior as it's happening, not go ahead and recreate it. So that's building in and virtualizing the capturing of virtual system and the code. Again, Exalogic doesn't do this. Right, they're engineered, as Steve showed, for more single use. If you want a database system, you get a database system. PureApplication System is balanced. Right? We support a variety of workloads. We support a variety of patterns that mix application and data logic. no virtualization. So everything I'm talking about, pattern-based deployments, this whole molecular thought is not part of that. They lack elasticity and this notion of problem determination the way I've described it. Zero downtime. And this really gets into our design point number 5, really focused on optimization and automation. We have a really cool, compelling way to do that. We do upgrades and maintenance. Yes, maybe not the sexiest stuff in the world, but if you have to upgrade a system, that's top of mind. So we treat it, think about how the ocean tides work, right? So the tide goes out, we move workload to one corner of the system, we apply service and maintenance to the vacated area. When the tide rolls back in, we move the workload back, right? So using intelligent placement and movement of workloads, we have algorithms around that, very sophisticated, but all built in. Footprint savings, I like to say, take out your rulers, measure a square foot of rack space, and we've done work to ensure that we can pack more enterprise applications in a square foot of rack space than our competition can. And again, that's not a marketing boast, right? That is a fact. Fact based on things like our Java optimization around resource. When a Java instance starts up, if another instance is already running, there's a lot of common code there that we don't reload. We just kind of point to that. So when we start up, we can start up very quick, and we're not going to take up as much space on the second, third, fourth, and fifth instance. Right? So again, dense deployments. Steve also mentioned some of the database technology around real database compression. Right? We have benchmarks and statistics that can show this. And speaking about statistics, as our data services are running, we are gathering statistics on the usage and the access of the tables, and we're optimizing that. So we're continually doing query optimization. Again, built inside. And again, from the competition perspective, it's not there. In fact, when you look at the cost structure and lay it out, based on the density metrics, based on the labor that you have to do to build out your own scripts for doing maintenance, upgrades, rollout, the savings is significant. Right? Again, the life cycle part is a key part of this. And we don't leave the life cycle to chance. Again, we've prescribed that, we've documented that, and now it's open and available through a set of tools. Less defense, density, messy upgrades, and extra DB server required. So again, that's how kind of we stack up there. Let me give you a quick run through. This is our app store. This is the Pure Systems Center, and it's where IBM and our ISVs put these expert patterns. Let's browse the catalog. Here's the catalog. One of the things you'll notice is people have been populating the catalog. This has only been out for a couple of weeks. We have over 80 patterns for PureApplication Systems alone, 5 by IBM, and it's 5 because we have a bunch already on the system, and 76 from partners. So pretty impressive. The partners have been building their own expertise into the system quite well. So let's pick one of the IBM ones. It's a very simple one. Here's the single pane of glass. And what I want to do is work with a virtual application. When you work with a virtual application, we hide the middleware. So you're only dealing with application constructs. We're going to use something called a virtual application builder, and that's what you're looking at right here. And I picked, as I said, from the catalog, a very simple web application pattern. And a web application has 2 components, an application and a database. And that's what you see here. Very clean interface. So let's pick this, and let's put it on the canvas and start working with it. The first thing we want to do is add an application. So we have a financial trading application, a sample that we use internally, and that's what I'm demoing here. And what you do is you drop the application on the application icon, and you do the same with the database to define the database. And that process is through a simple set of dialogues. Again, you're not going into the product console, right? You're doing it from a very simplified set of instructions. Well, this is a pretty simple pattern, and if you want to enhance it, on the left side here, there's a pretty complete set of componentry that you can drag and drop to enrich your pattern. You can enrich it with things inside the box, Or you could connect to existing things in your enterprise. Again, we want to preserve application compatibility. So if you have a database running on Z-Series, you can drag and drop an icon there to connect to a remote database. Heck, that remote database can be an Oracle database. Again, messaging components, message queue, topic, you can add those to the pattern. You can connect to Kix through the Kix transaction gateway on a mainframe. Right, so these patterns could interact with things on the box, but also outside the box too. Again, supporting application compatibility. Now, if you were to deploy this pattern, we have an expert system that looks at the design and then derives from that design the running system. And in this case, 2 virtual machines, one containing the web app part, the other containing the database. Pretty simple, and it's done by us, right? This is stuff you don't have to know how to do. And this is a simple, probably, development topology. And let's then maybe make it a little bit more interesting by, remember I talked about behavior? Let's introduce some behavior. In this case, the behavior is scaling behavior. In other words, as load increases on this application, you need to change the way the application is running a bit. But you don't have to do that manually. All you do is you drop a scaling policy. And the scaling policy allows you to specify things like, if the CPU goes above 80%, we'll start adding more instances of the web application until you hit 10 instances. Right? So think about the labor. Think about the skill to do this. It's a simple deployment policy. We have security policies. We have routing policies. We have a number of policies. We also have an API where you can add your own policies. And again, not only are people putting patterns in the pattern repository, but they're doing things like working on policies and the like. Oracle has coherence as their caching technology. Caching is very important to getting scale and high availability. We have a very competitive set of caching technologies that I personally have worked on called Extreme Scale. With a single click, you have all of the power of Extreme Scale brought to bear. Again, Oracle does not do that. It's quite complex. There's similar multi-inch books on how to configure that. So if we were to save this and deploy it, now some interesting things happen. Right? We have a scaling policy in there. So now the configuration is a little bit more complex. But don't worry, this complexity is handled behind the scenes for you. So in this case, we have a cluster of app servers connected to a database that's highly available and talking to storage. We are using caching, so we call upon a caching service, and we need to call on a proxy server because we have to spray work out to the cluster. If this sounds like gibberish to you, very simple. This is stuff we do, you don't have to. This is the built-in expertise that's generated under the covers. All right, so you deploy that, and the first instances of WebSphere and DB2 start in 10 minutes from bare metal to a running system with elasticity and high availability. They're secured, they're monitored, all from this single pane of glass. All right? So pretty revolutionary how we've taken this. And again, not just our expertise what this is showing, but again, ISVs and customers could also capture theirs. Speaking about single pane of glass, let me finish off the demo by just showing you some of the integrated hardware. So we can go back to that, click on hardware. Here's a hardware depiction of the box. And you can actually, through this graphical interface, click on top of rack switches, get error messages, warnings, events, look at heat, and et cetera. Again, all without having to leave this common integrated console. My last point is, we want you to come on over. We're open. We're expert. We allow you to participate in our ecosystem and contribute your own expertise. We have tools that help you migrate. Very complete, very compelling. We have support and services behind it.